Good evening, everybody, and welcome to another episode of vBrownBag. Tonight is going to be a continuation of the Python for DevOps series, talking with Python developers and learning how to level up our skills. Tonight, I'm very excited to be presenting Ali Spittel. I'm sorry, Ali, is it Spittel or Spittle? Which do you prefer?
It's Spittle, but don't really care either way.
Presented by Ali Spittle. Yay, Ali! But before we get into all of the Python excitement, let's go through a couple of housekeeping notes. Getting on the conversation. If you @ vBrownBag or hashtag vBrownBag, both Joe and I will be paying attention on the back end to make sure that all of your questions are answered. We will also be taking Q&A from the live studio audience as well. And again, tonight our guest is Ali Spittle. And Joe, are you there?
I am here.
Joe is going to be co-hosting with me. My name is Chris Williams. I am at Mistwire. Joe, introduce yourself.
Howdy, y'all. I'm Joe Hughes. I'm at J Hughes, based out of Austin, Texas.
Awesome. Very cool. And so with that, Ali, let me pass the power to you.
Cool.
And yes. Awesome. Moving past tutorials. I see it.
Awesome.
Awesome. Let me go to full screen. Cool. So today we're going to talk about problem solving for programmers and moving past the cycle of tutorials. So essentially the problem that we're going to be talking about is that you know the pieces individually. So you know what a for loop is, you know what a conditional is, maybe you know what a function is, and you can follow along with tutorials when you're working through those. But the hard part is trying to put those things together. And so a little bit of an introduction to me. I was a software engineer for a decent number of years, and then I transitioned over to teaching other people how to code. I started in person at General Assembly, which is a coding boot camp, and now I teach people online through blogging, and I'm back to being a software engineer and what's called a developer advocate for an awesome community for developers called Dev. So I've worked with a ton of junior developers and have worked with a bunch of beginner programmers to see them start their coding journey. And in my experiences with all of that, I've really noticed that the thing that people struggle most with is, especially at the beginner and intermediate levels, is putting the pieces of programming together and knowing which pieces to use in which context. And most programming contexts or courses don't actually teach that context. They teach everything from top to bottom and how to put the and what pieces to use, but then they don't actually show you how to put those together and problem solve for yourself. So that's what we're going to talk about tonight. So the roadmap is we're going to talk about how to plan for projects and even pick a project in the first place. We're going to talk about breaking down problems and how we would do that. We'll also talk about something called pseudocode, and then how to actually put those pieces together and write the code yourself. We'll also talk a little bit about debugging and refactoring your applications so that they're easier for other people to maintain after. So the first step in the process is having a project. And in a lot of cases, this will be given to you through either work or through some education program. Maybe you're in a boot camp or in a computer science degree. But sometimes if you're self-studying or you're trying to do a side project, you're going to have to come up with that project yourself. And in that case, there are a couple places you can look. So I love solving code puzzles. They're not super real world, but they're really fun for learning coding concepts and really challenging yourself. And I love how they have different levels on them so that you can pick something that's really tailored to where you're at right now. So some sites to find those coding puzzles include CodeWars, HackerRank, and Project Euler. Project Eulers are pretty mathy, but the other ones have a huge range of problems.
Is that how that's pronounced? Euler? Okay. I've been calling it Euler for a while, but it's Euler. Okay, thank you. I didn't know that.
But Euler's the mathematician, yeah.
Okay.
German?
Thank you.
For sure. So these are great for flexing your problem solving skills, but don't necessarily look like real world applications. So another thing to do is to build an actual application. So I always try to give the advice of thinking of the subfield that you're in or what you want to do in the future. So if you want to work in the insurance field as a programmer, or if you want to work doing game development or doing data science, think about the different problems that you'll find within that subfield and try to find a problem or a project that you could build that would show off those skills, and try to do something that's a little bit outside your skill level so that you're growing. If you're not challenging yourself, then you're not growing. I also have a link that I can send out in the chat for a bunch of different application ideas. Let's see.
Awesome.
I know how to do this. Here's a great article for a bunch of different app ideas.
I will add those to the show notes as well when we're finished.
Awesome.
Every time you
Awesome.
put the to-do list, a puppy dies. That's fantastic.
Yeah, I hate the name. It's so sad, but it's a great article. It's a pretty funny name, but it is a little bit sad as a puppy owner.
Oh.
So then once we have a project that we're trying to build, we also need to decide what tech and tools we're going to use. So think about what the problems are that you're going to face and what technologies are going to be best to solve that. So do you need an application that's super, super fast for the user, or do you need something that's more developer friendly? Do you need something that's data science focused or a web app? Do you need a huge web app or a small web app? All of those different decisions go into deciding what tools and tech you're actually going to use for your project. So that's kind of the next step in the process. And if you don't know the tools and technologies that you're going to need to build that thing, you're going to have to learn them. And so I know the title of this talk is Moving Past Tutorials, but a huge tip here is to actually use tutorials, but only use one or two. What I see a lot is that people get in this cycle of tutorials. So they keep doing more and more and more tutorials on the same topic, but they're not actually building anything with that, and they're still not fully grasping it. So instead of getting stuck in that cycle of just doing more and more tutorials, instead do a tutorial. If you don't understand that tutorial at all, then do another one. But once you at least somewhat conceptually grasp what's going on, then go ahead and try to build something with that. And so this is where our project comes in hand. So you're still going to have the tutorial to rely on. If you forget something, you still have Google available to you. And if you forget the details, you can come back. But you're going to have a much better chance of understanding something if you build something rather than just reading about it a bunch of times. Also, when you're going through those tutorials, make sure that you're actually writing down the code yourself instead of just copying and pasting things in. It's not going to make things stick for you. If you write things out, then that will probably help you more. So the next thing that we need to do once we have our tools in place, we somewhat understand the technology that we're trying to use, we need to understand the intent of what we're building. So if the client is you, if you're building a side project or something like that, the intent is pretty obvious because you're the one deciding that intent. But in more real world situations where you're working with a company or something along those lines, then we're going to need to understand their needs for this application. So whose life will it improve, who will be the user, and understanding that context is going to make you able to implement features in a way that's going to benefit those end users. It's also going to give you a purpose when you're coding. So make sure you're asking questions in those client meetings or whoever you're interacting with in order to fully understand the problem. And if you're doing coding puzzles, think about why you're doing those puzzles and what you're trying to learn from them. So for example, in college, linked lists totally tripped me up because I didn't understand why we'd ever need them because we had arrays. And if I had understood why we needed linked lists, then that would have totally changed my whole learning process. So make sure that you're thinking about that why and that intent in order to really drive your learning. So once you understand the why and the intent, you also need to know the features or the what of what we're building. So what are the attributes that are going to make up the final project? What does the client want the project to include? How do those need to be implemented? Which ones do you prioritize? And make sure to ask questions to get those details. So which ones are most important to the end user? And make sure that you're writing these things down. Even if you're given an assignment verbally, writing down your thoughts is still important. And if you're getting the instructions verbally, make sure that you're taking those notes so that you know exactly what you're trying to do. So trying to remember the discussion or the specifications after the fact and relying on your memory alone is really difficult. If you write down your thoughts, then those are permanent and you'll have more of a chance to revisit those after the fact. So I use Google Keep for writing my notes, and I don't worry about formatting at that point. I come back and format stuff after the fact. I just write and try to get something down. And if you're getting the assignment in written format, like maybe for a school project, make sure that you're reading through the assignment a couple times and ask any contextual questions you have. So the next step in the process is identifying the minimal viable product. So now you understand what you're trying to build and why. Now you have to identify what the minimum thing that you could create that will still benefit the users and that can still go out into production. So what is super necessary and which things are bonuses, and make sure to put it in a list so that you know what you're trying to achieve first and what you can ship, and then worry about the bonus features or the extra features after. So I try to create a list with priority levels according to those different things. So I'll make to-do lists or use Asana or GitHub or Trello, whatever we're using as our product management system, so that you know what features you have to do and which ones you'll do after you finish that MVP. It's a little bit dark, but also think about what could go wrong in this whole process. It's kind of pessimistic, but think about the blockers that you may run into, what you may have to learn along the way, and what parts of the application will be hard to build. So if you're drawing out a timeline, all these factors are super important. And don't be super optimistic on timelines, even if it makes you sound better, because you may not meet that, and that looks worse than being super optimistic at the forefront. So try to extend that deadline to think about what could go wrong. So once you have that MVP, if you're not working with a designer, which you may be, but if you're not, then I would go ahead and try to make some wireframes or low fidelity sketches of what your application may look like. Doesn't have to be super fancy. You don't have to be a designer, but just thinking about in general what this may look like to the end user, what things may need to be included there. And there are softwares that help with that too. So Sketch and Figma are two that are really designer focused. Sketch is what I personally use, but if you're trying to just sketch something out and think about it in the really high level, Balsamiq and Wireframe are two free pieces of software that can totally help with that as well. Just having an idea of what you're building makes the coding process a lot smoother. So we talked about thinking about the worst case scenario and what you're going to run into, but sometimes you'll have a timeline given to you, sometimes you have to give that timeline back. So be realistic here, but also hold yourself to those deadlines and make sure that you're doing that MVP, that minimum viable product, before you do any of the fancy stuff, because having something to ship is so much more important than perfection.
Quick question about wireframes.
Yes.
From the audience, I'm not familiar with the concept of wireframes. Is that similar to a mind map?
So a mind map would be where you're like writing out all the different features and how they flow, I believe. The wireframe is more if you're trying to build an interface or maybe a data science app or something along those lines, just a rough sketch of what you want that end product to look like. So if I were to do a wireframe of Twitter, maybe I'd have the nav bar up at the top and different tweets and then a person's profile on the side, but none of the fancy colors and none of the really detailed things, just a high level sketch of like what will be on that end user's page.
Okay, cool, thank you.
Totally. Okay, so quick transition. We now have talked a little bit about the planning process and what that first step is going to be. The second step of the process is probably writing pseudocode. So have you ever stared at a blank text editor file with no idea where to start? I would probably guess that the answer to that question is yes. And if at any time you feel stuck when you're writing code, writing pseudocode is something that can really help with that. So you're thinking about the steps to solve a problem, and you're writing them in plain words instead of any actual programming language like Python. And you're doing it in a way that makes sense to you. So first, we need to think about the parts of the problem. Computers are super literal, so you have to think of all the tiny details and include them. And if we're skipping over things, then we may have issues down the road. An exercise I like to do with students is have them pseudocode out me making a peanut butter and jelly sandwich. And it sounds easy when I'm saying it to you right now, but inevitably something goes wrong. Like they forget to tell me to put down a knife or something along those lines, and I'm trying to carry the knife while I'm doing all the other steps of making a PB&J. So to think about every tiny little detail when you're doing this in order to make your actual code easier down the road. So for example, I could write pseudocode for taking my puppy that I was talking about a little bit earlier out. So the first step in the process would be finding my shoes, but my shoes aren't always going to be at the door. So if my dog had stolen them or I put them somewhere, then I'd have to find them. If it's cold out or I'm going on a longer walk, my shoes are going to look different there, and I may need to find socks. And then if I need socks, then I have to put them on. And all these steps are outlined here. So this isn't actual code. This isn't what we would actually run for our application or our script. But we've got all these steps written out in English. And you can start seeing some patterns here, like if, then, when, all those things. Like you can start to maybe think, what might this look like in Python? And so if we refactor this a little bit, it could look like this, which looks really, really similar to Python code. So if it's cold, wear boots. If I'm going for a long walk, wear sneakers. If my shoes aren't at the door, find them. And then I have an else statement there too. So having these different transitions of pseudocode and these different steps in them is definitely important for our thought process, and having something at least down on paper so that we can keep refactoring it to the point where it's actual code. So this still isn't like compiling code. This isn't going to run, but it's a pretty good first step.
So a couple of questions.
Yes.
So first of all, we had one from the audience, which was, why would you start working on the UI before the actual code? So when we were talking about user experience, I guess like why are you more focused on visually what it looks like rather than the code first?
Totally. So the planning process, if you put a lot of time up front into planning, it's probably going to save you time with code down the road. It's also an iterative process. So you can keep going back to your client or your employer and say, okay, here's what I have on paper. Can I go implement this in code? Because it's most likely going to take way less time to put something down on paper than it is to actually write the code for that thing. And so you're a couple steps ahead if you at least get the visuals approved before writing the code for it. And then along those same lines, if you have a plan in mind that you're aiming for when you're writing code, you're probably going to have like a better end result because you've got something in mind that you're actually working towards. And it's also going to help this problem solving process. Instead of just writing code and seeing if you like the output, you have an output in mind that you're trying to work towards.
Okay. And another question. So when you're writing pseudocode, and especially if you've got in your mind the wireframe or the interaction that somebody's going to do that's going to actually drive that code on the back end, while you're doing this pseudocode, what do you have as far as recommendations for people to like try and break out and identify the minimum viable product portions that they need to focus on first, and leave things that are kind of more advanced feature requests out, even if it's still structured in the same way that it should actually flow in the code?
Totally. This is actually what I'm transitioning into now in my next couple slides.
Got it.
But essentially, a quick preview, break each feature out individually once you have the MVP, focus on the features first, and write the pseudocode for them, and then actually implement them, and then come back to the pseudocode for the bonus features. So we talked about these two different categories of problems that you may run into. So the first ones were code challenges, like from CodeWars or from Project Euler or something along those lines. And for those, I really like solving them on paper first, because the kind of puzzle nature of them, it makes it nice to solve them out first. So a classic example of a coding challenge like this would be to reverse a string. So if I were to reverse a string on paper, it would look something like this. First, I've had the each, then the EH, then the LEH, LLEH, etc. So I've solved the problem on paper, and I've really thought it through and thought about the different steps that it took me as a person to write these things out. And so now I could write the pseudocode for that. And if I'm doing something repeatedly in my code, I know that I need to use a loop, and I'm definitely doing that in this case. I'm taking the first or the second letter and adding it to the beginning of the string, then the third letter, adding it to the beginning, fourth, adding it to the beginning, etc. So the pseudocode could look a lot like Python in this case. So I don't have the colons and nothing's perfect here, but I'm doing something a bunch of times, so I know that I need to have a loop. And in this case, I'm going to use a for loop since I'm looping through the letters in a string. And then as I'm doing so, I'm creating this new reversed string, which is the letter that I'm currently working with prepended to that reversed string. So I really thought through this process, first on paper of just solving the problem myself, and then by writing the pseudocode so that I have something at least on paper, even if it doesn't work perfectly in the language that I'm working towards. Python is really nice that it almost looks like pseudocode sometimes, depending on your style of pseudocode, but that's just a feature of the language and is probably less true in other languages you may use down the road. So we've talked about coding puzzles, but applications are probably what you're trying to work towards, whether that's a data science application or a web application. And we talked about outlining our features and prioritizing them to the MVP and the bonus. And so what I would just personally do is take that one feature and at a time and write pseudocode for it. So one thing that you may have, and there's some jargon on here that you may all not know, and that's totally fine. So do one feature at a time instead of the whole application, so that similar to what I was saying before, if one piece of the app changes, if your client decides to do something a little bit different, your work wasn't totally in vain and you don't have to start totally all over. You can just change that one feature. So it may look like this. So in this case, this is the pseudocode for a form. So a modal is like a pop-up on a website that may have a form in it or something along those lines. And so in this case, our pseudocode may look like a user clicks on a button, and so this pop-up pops up with a form with a field name, an address, and a phone number. And those are the different fields on the form. And then the user submits the form, and that's going to go try to send a request to the server with the values from the form. The pop-up closes, and if the form is successful, then we'll show some sort of success message, else an error message. So this isn't code, but it's getting us really, really close. Like we have these kind of conditional statements written out for us. So again, pseudocode is a great tool to use, and if you're staring at that blank text editor, not knowing where to go next, then I would try to write that pseudocode and break down those features in that way. So once you have your whole entire process outlined, you have your features planned out, you've got your MVP, you've pseudocoded your application or your feature. Now you actually get to the coding process. And hopefully this process is a lot easier now since you went through all of that extensive planning. You've already gotten a huge chunk of the way there. And writing the code should at this point be close to just getting the syntax down on paper instead of actually doing the problem solving while you're coding. You're separating these processes out so that you're thinking through the problem, thinking through the pieces that you're going to need, and then writing the code afterwards. As you progress in your career and you get further and further along, these things may condense a little bit. Like my pseudocode doesn't look like this anymore. It looks more similar to actual code, but it's still really helpful to get those thoughts on paper or on your text editor or something along those lines before you're actually writing the code. You're planning through the process before actually doing the implementation. So now I have advice for when you're actually going through the coding process. So the first one is to solve small problems, not big problems. So you're trying to make these steps in your pseudocode as small as possible. And the same thing with your features when you're trying to identify those at the beginning of the process. And so an analogy I like to use is I am really big on writing to-do lists for things. So I have my tasks for my day all outlined for myself. And I try to make those steps pretty small so that I'm getting quick wins. So I'm just achieving these things and checking them off my checklist. And I think the same is true with code. So you have these problems broken into really, really small little chunks. So you can solve them all individually rather than trying to focus on a big problem, because big problems are difficult and solving a big problem all at once is really hard. But solving smaller problems individually is a lot more achievable. And so I view your application as a set of small problems rather than a huge one. The smaller the problem, the easier it is to solve and the more you can achieve. So break these down into as small things as possible. And making these problems and doing the pseudocode and all that should be the bulk of your time.
So what do you recommend as far as like a testing cycle or how often people should validate changes that they're making within their code? Like even the first time they're writing an application, at what point should they stop and make sure that a problem that they have is a minor one?
I think at least when you're starting out, like anytime you write a piece of code that you think should work, test it. Like even if that's a line or half a line or you change one tiny thing, check it at that point, especially when you're starting out, because trying to debug 20 lines of code that you just wrote and there may be 20 errors in there and you don't know which ones are which and where the error is actually coming from, that's really difficult to do. But if you just change one line of code and one thing in that line of code, if you knew that something's broken, you know where to look to try to fix that problem, most likely. And so I would try to run that code as much as you possibly can in order to keep seeing those changes, keep seeing to see if something broke, at least at first, and then you can work your way up from there once you get used to that. And then another piece of advice here is that when you're trying to solve a jigsaw puzzle, you do so methodologically. So instead of trying to just fit random pieces together and seeing if that will work, you normally solve the outside first, and then chunks of the puzzle that are build up images. And so the same is true for code. Build things methodologically instead of just guessing at things and trying to fit things together. That's going to be a hard process. But if you slow down and actually think about the pieces and put them together in a way that you've thought through, that's going to be a better process. Another piece of advice is to draw on similar problems that you've already done. So have you seen this problem before or something with a similar pattern? And maybe you have, and there may be differences, but you can at least start with the previous solution that you had and try to tweak to fit this similar problem. You could also try to fit the different problems that you've seen before together and use that knowledge that you already have. No problem is going to be completely unique. It's probably going to be a accumulation of other problems that you've solved. And you're essentially just putting this tool set that you have together. So the fundamentals of programming are essentially loops, functions, classes, conditionals, and then you have your math and your variables. And there may be fancier things that you can use too, but essentially these are the basic concepts, and you're putting those together to solve any programming problems, and don't lose sight of that while you're trying to solve through this. So draw on the similar things that you've solved and focus on those pieces and putting them together. Also, trust yourself. So trust yourself to try writing code without a ton of help at first. So you've gone through your pseudocode, you've tried to learn the language at least a little bit and the tools that you're using. Something that I see a lot is that people will Google something right away before trying to solve it themselves. And if you try to solve it yourself first a couple times, and even if it doesn't work perfectly, just trust yourself for a little bit first, and that'll be really effective for your learning process. And think through why it's not working, debug it methodologically. Don't immediately just Google it or ask somebody else. Try yourself first, and that will be the biggest benefit to the learning process. Along those same lines, Google things effectively. So Googling for help is something that you will do all the time as a programmer, and it's super, super important. There's nothing wrong with it whatsoever. That being said, it can be really harmful if you're solving or if you're Googling the whole problem rather than a part of the problem. So sometimes I'll give my students a problem like create a tic-tac-toe application, and they'll Google tic-tac-toe application Python, and there are a bajillion code examples on the internet for tic-tac-toe and Python. And the problem here is that looking at somebody else's Python code and adapting it to your solution isn't going to be super, super helpful, at least when you're learning. The hardest part is going to be breaking it down into those sub-problems, solving those independently, and working through the bugs that you have. So instead of Googling that whole entire problem, instead of Googling reverse a string in Python, instead Google the error message that you get. Or if you forget the syntax of a for loop, look that up instead. Something that I even recommend as a tough challenge for yourself is create a cheat sheet for all the syntax things that you need and really read through your error messages for a little bit, and then cut out Google for a week or two when you're programming and see how far you get and see how much it improves what you're doing. Use Google after those 1 or 2 weeks, because Google is an important skill to have and it's an important technology to use as a programmer, but trust yourself for a little bit and get good at coding on your own without it sometimes too, especially if you find yourself trying to Google the whole problem instead of parts of it.
I think Chris thinks that was blasphemy.
I think I did too before working with a ton of students, to be totally honest.
So how does that help? How does abstaining from using it? I mean, obviously you don't want to just find the quick answer and you want to think about the problem. But in your experience with your students, how do you see that as a force multiplier?
Totally. So if you have this cheat sheet with just the pieces that you're trying to solve, right? So you have like the syntax for a for loop written down, the syntax for a variable, all those things written down
I see.
on this cheat sheet that you can use, then you're focusing on putting those pieces together rather than searching the whole problem over and over again.
Gotcha. Okay, that makes
And
sense.
I only recommend doing this for like a week or something along those lines, or maybe just one project, because I think that learning how to use Google is like a super, super important skill as well. But that being said, I think that focusing on putting the pieces of the puzzle together are really important too.
Well, and it seems like once you've got the basic stuff down, that just having that available as like a snippet is probably the better thing than a cheat sheet you've got to keep referring back to, I would assume.
Yeah, totally, totally. Cool. So another thing to focus on is failing fast. So this doesn't mean that you're actually failing totally, but instead of going or spending a month going in the totally wrong direction for a feature, or writing 100 bugs and then debugging those 100 bugs all at once, you want to know as soon as possible when your code isn't working. So if you're using automated testing, that may help, but make sure that you're actually running your code as you go, that your desired inputs and outputs are matching. And if you add a line of code or two, make sure that you're running your program in order to make sure that that works. Also, make sure that you're being in touch with your project manager or your client or whoever's in charge of that, and making sure that your feature is actually going in the right direction. So another thing to do is to make sure that you have sample inputs that cover edge cases. So you may, like a common edge case would be handling null values. So none in Python, also zeros. So your code breaks when it's supposed to break, but it also doesn't break when it's not supposed to break. And so make sure that you're testing your code and seeing that it works, or that it doesn't work when it's not supposed to work. And another important thing to do is to take breaks. So sometimes writing code is really frustrating, and know that that's totally normal and happens to people who have been working in the industry for a while too. And your frustration probably won't help you debug faster. It'll just make you unhappy and more blocked. So take a walk for a while, you'll step away, and when you get back, you'll probably be in a better headspace. I would also recommend the Coursera Learning to Learn course. It's just like incredible. And one of the big things that they focus on in there is that taking breaks from learning a certain topic and learning from in general is like one of the best things that you can do in the learning process, and it'll help you down the road in order to solidify concepts. So highly, highly, highly recommend that, the Coursera Learning to Learn course by Barbara Oakley. She also has a book too, but I haven't read it.
So we had another question that came in a little while ago. Would you build a test harness for functions?
A test harness for functions. What? Can you clarify a little bit more on that?
Yeah, waiting for.
Okay.
Yeah, we can come back to it.
Yeah, we'll move on.
So another thing that you're probably going to encounter is bugs. So your code probably is not going to work straight off the bat. And this is something that I really, really struggled with when I started programming. Like, there's so much pressure to be perfect out there. And so seeing this red error message and seeing that your code isn't working can be a little bit discouraging at first, but it's actually a programming language being really nice to us and telling us that something isn't working. And if you read that error message close enough, you can probably figure out from that error message what you have to fix, or at least where to look, at least usually. Especially Python has pretty good error messages. So one thing that you can do is print your variables out using print statements. And so you can walk through your code printing out what different variables are at different points, and that will help you debug there. But my favorite tool is Python Debugger, or PDB, and this will allow you to add like pausing points to your code. So it will open up in your, when you run your code in your terminal, it will open up REPL, so similar to like IPython or any other REPL. You can actually interact with your code at the point that it's stopped at. It's like a pause in your code. And this is like a magical tool and something that I would really, really experiment with. It's totally changes the debugging game.
That is a fantastic segue for everybody listening. If you did not see Chrissy Wainwright's talk on 717, Python debugging with PDB, now would be a good chance for you to click back and check out the previous episode as well.
Amazing.
Thanks for the plug, Allie. Awesome.
Yeah, totally. That's awesome because she goes way more in depth, I'm sure, too. So
she totally got into everything, stepping and going into functions and not functions. It was a great talk.
Okay.
Yeah, PDB is amazing.
Yeah, it really is. It's like one of my favorite tools. And I'm shocked by how few people know about it, too. Like, even experienced programmers, I sometimes am talking to them and they haven't heard of it. So definitely check it out. And going back to my initial kind of segue into this section, love your error messages and actually read them too, because they're really helpful and will almost always tell you at least where to look and what might go wrong. So don't just ignore them. Don't just say there's an error message there, I'm just going to go back to my code and read my code. No, read through that error message, look at the line numbers it's mentioning, all of that, because that's important too, and will help you get closer to the solution. Okay, so now we've planned through our code, we've pseudocoded it, we've written the code itself, we've debugged the errors that we've had along the way, and now we're going to talk about refactoring. So refactoring is the process of making our code more understandable and maintainable so that somebody else in the future can help out with our code, or even just our future selves. We can go back to it and understand what's going on and have code that we can easily add more features to or update when a new version becomes available. All of those things are really important for building software that lives a long time. So Python actually has this Zen of Python program poem built into it, and I love it. My blog was actually named after the Zen of Python for a long time, and I have it framed up in my apartment as well. So I would really, really read this and internalize it because it has so many great rules for programming and writing code that other people can understand. So things like simple is better than complex. Your aim is not to write this super, super complicated code. It's writing simple code that other people can understand. Readability counts. Somebody reading through your code, that's important too. And errors should never pass silently. That's another great rule there. So definitely read through this Zen of Python. It has a ton of wisdom in it. And it's something that I think all programmers can deal with internalizing a little bit more.
I love the now is better than never.
Oh yeah, I love the Easter eggs in it too. Like there should only be one and preferably only one obvious way to do it with the minus signs.
Right.
That's a great Easter egg. Okay. So some rules for this debugging process that these fit into that Zen of Python. So use clear variable and function names. So I see a lot of like one-letter variables or function names that don't really explain what the function is doing. Make sure that those are clear and that somebody else down the road can understand. Also, write functions that do one thing only. So instead of writing a function that does 18 different things and handles your whole program from top to bottom, they're more understandable, readable, and maintainable if they just do one thing. If you have some sort of bug, when you have a short function, it's easier to find the source of that bug because you can go to the function that is handling that piece of logic. And your code's going to be more reusable. You can use that function in other pieces of your code. So if you're writing a function that could be named with an and in the name, it should really probably be two functions. Also, write documentation. So two tools that I love for writing documentation in Python are Sphynx and Google Docstrings. Google Docstrings are a way of formatting Python documentation so that the different variables and functions and arguments and all of that are explicitly laid out and explained, and there's even like sample code in there. It's a great way so that somebody else reading your code down the road can understand it. If you have an open source library, especially, other people can contribute to it. And then also Sphynx actually takes those Google Docs strings and will build like a documentation website based off of that. So it's a really cool tool for that as well. And a general rule of thumb, if you're writing comments in your code, is to use them as the why of your code instead of the what. So why is your code doing what it's doing? Why does your code look the way it does? Those are important questions to answer for the next person that's coming along. The next slide's a controversial one. And you definitely don't need to follow these rules explicitly, though I think 3 or 4 years ago, decided to challenge myself to do this for one project, and I've kind of stuck with it because I think that it ends up in really maintainable and readable code. So I definitely go with these. You don't have to, they're controversial, but essentially classes can be no longer than 100 lines of code, so make sure that your classes are relatively short. Your methods and your functions can be no longer than 5 lines of code, so that makes them pretty short as well.
Wow.
Yeah, that's the really controversial one usually. And I think that like 7 to 10, I think a lot of people use 7 to 10 instead, and I think that that's a fine rule as well. But I think just thinking about it in those general terms of, okay, it's going past that 7-line mark, maybe I should refactor this into 2 functions. Pass no more than 4 parameters into a method, and then this is kind of less relevant for this discussion, but controllers can instantiate only 1 object. So these rules are super, super strict, but I really like them. They're something that I use personally, and so I wanted to include them for that reason. Also, you should go watch all Sandy Metz's talks because she's the best. Also, Python has a whole entire rule set built into it for how you should format your code, so there shouldn't be too much controversy there. It's called PEP 8, and PEP outlines a bunch of different rules for Python and for, it's like Python enhancement project. And so, or something along those lines. And so another rule here is that code is read way more than it's actually written. So instead of everybody just writing new code and that being the way that things go, you have to read a lot of other people's code and understand what they're doing and understanding that code in order to write your own. So Python has all these rules, such as 4 spaces for each level of indentation. Lines must be less than 80 characters long. Use absolute imports. So all these things are outlined and they're all written out for you to read. You can use extensions within your text editor or something along those lines that tell you when you're breaking these rules. And so just generally following them is the best practice. So throughout this talk, we've gone from the planning process into the pseudocode and the planning process. Then we've talked about writing the actual code, then debugging, then how to clean up that code and follow best practices. And that kind of brings me to the end of my slides, but I can definitely answer any other questions that you all have for me.
I'm currently looking up Sandy Metz. Holy mackerel, she's amazing.
She is. Her book, Pooter, Practical Object-Oriented Design in Ruby, is like one of my favorite books ever.
And I was not following her. I'm gonna now. Yay, new follower. Awesome, cool. Joe, sorry. Have any additional questions have rolled in? I was fanboying over Sandy. Joe, are you there?
Yep,
Joe,
I'm here. Sorry, nope, I'm here. Yeah, no, I was double checking. I didn't see any in the background.
Cool, awesome. Ali, this was absolutely fantastic. Thank you very much. So what I'll do is I'll take all of the links and mentions that were in your talk, and I'll add them into the show notes. Folks are saying thank you, great job, appreciate it. That was fantastic. That was super fun and very informative. Awesome. What's the next thing that you're going to be doing with? Is it called dev.to, dev2? What do people commonly call that?
Yeah, so dev2 is a community for developers. I'm always trying to get more Python content on there because I'm originally a Python developer. That was my first programming language and where I worked for my first couple of years. So I'm always trying to get more Python content on there. So if you have Python blog posts or anything along those lines, please cross-post them. You can use a canonical URL, which is how you keep your SEO intact when you're posting blog posts to multiple places. And
cool.
You can write about anything on there, and it's a great place for gaining some traction for those blog posts. So awesome community, super, super supportive. Can't recommend it enough.
Then I will start cross-posting my Python stuff from my blog. I'll hit you up on that, definitely.
Cool.
Cool, awesome. All right, one last quick peruse. Solid presentation, Ali. Great presentation, thank you. Several comments and positive affirmations, but no additional questions. I think we've gotten them all. That was fantastic. Thank you, thank you very much for doing this for us tonight.
Thank you.
Cool. All right. Well, everybody, thanks very much for yet another vBrownBag. Have a great weekend, or actually, wait, no, have a great week, and we'll see you again next Wednesday.
Bye.